So hi, today the main topic is the B-tree insertion part and how did I implement it. Um, if you guys don't know about B-tree insertion, and I'm just gonna explain this kind of really fast. So basically, example you have bunch of listed bunch of value that you want to insert. Example, whatever fours, 5, 2, 1, 3, 10, like this. And let's say our minimum degree is actually 2. So our max case is gonna be 2 times 2 minus 1 is 3. Also mean case is gonna be 2 minus 1 is 1. So this is it. And next part is, yes, you just have to make just the simple node first. So if there's no other parents of it or other children's, or even, yeah, if there's no other parents, so this node is gonna be for the root of the B tree. Let's first insert 4, and now let's insert 5. And now let's insert 2. Since the B tree, the key, the in the node, this the key has to be sorted like this. The reason why it has to sort it because if it's if this key's length overflows the maximum case, we have to find the primary index of it. Where primary index is t minus 1, so there's gonna be one index of it. But if the elements of in this list isn't sorted, this and if I select the 5 as a primary key and make it as a parent, there's gonna be issue of it, because if it's like pointing this part, if the 5 is pointing 4 but it is right, that's not really B tree. So we have to sort it when we're trying to insert. And next thing is 1. If we try to insert the 1, we now find a problem that this node is already full. The max case of this node can have is 3. So we just have to get the target primary key, which is 2, because we just know the primary key index is t minus 1, minimum degree is minus 1. So t minus 1 is equals to 1, and this the one index in this array equals to 2. And we make the 2 as a parent of it. And then based on this index of it, we have to make the remaining as a children. Like this. So this is gonna really simplify our B-tree insertion. So the B-tree insertion basically, I have to store um on the left of the page of it. The insertion has to be only in at the page. And let's say it. Yes, so it has to be stored in the page. So but the other problem was the B-tree insertion is the propagation issue, because I just showed this these two has to be go to parents, so that's gonna be propagation for me. What I believe is that's gonna be propagation. But there's um but let's say we have lots of children, and these children and there's children, and if there's some kind of target children's, example, you're on the left, your left children's is already max, and you have to make selective primary key as primary index as the parent. You have to store in the parent, but also the parent that recently stored the primary key could make uh their own node overflow, so it has to do say propagation of it. um so that's kind of a difficult part of implementing the B-tree. I check if it is able to insert. If I am able to insert, I make it I insert in the page the target core key, and after that I re-reference the parent stack. Parent stack is basically it's just the array to memorize the past parent. And if the current, if there's some kind of instance loading um cause overflow, um we have to make these make this parent into propagation. Example, if the current page is full, we have to split it and get the primary key index and put it on the parent. So that's gonna be propagation. Propagation is basically there's a current page and parent page, um, and the split. So split into half is basically splitting the this page, this node, and this also requires split into nodes children also, because even though I split in the keys of the current node, I have to split as children, so there's gonna be really different split, because if there's no split on the children, there's gonna be issue of it, because right keys can be referenced the left children. So I have to split it, and after that I have to put into new parent page, and I have to research it, and now I have to put this new updated children into new parent page. After returning, we have to just re-reference it, and if there's none, we just have to return it. That was kind of journey to making B-tree insertion, but actually I already implemented B-tree insertion. However, this JavaScript, the reference led um more higher complexity when it comes to the bit deletion part. So I'm keeps on implementing the insertion, but with fully readable and maintainable code. So this is it. Have a nice day next time. Bye bye.